After a rough touchdown on Comet 67P this week, the Philae rover is now drilling beneath the surface to see what secrets the celestial body can reveal. Scientists hope to learn more about how our universe was formed. Dr. Angela Speck, the director of Mizzou's astronomy department, is our guest for this week. She starts off our conversation by telling us what a historic comic achievement this is.
Well, it's the first time we've ever landed on a comet. Actually, that's not quite true. There was the Deep Impact probe, but that was deliberately smashed into a comet. It's the first soft landing we've ever had on a comet, and from a technical point of view, it's amazing. And from the point of view of advancing science, we're going to get more out of this than just about anything we've done so far.
Now, this comet is older than the Earth, right?
Well, it's probably about the same age. So this is one of the things that we're trying to understand is that if, under the current understanding of formation of the solar system, we think that comets formed first, and then that the Earth is formed out of the same sort of stuff that all smashed together and stuck into a bigger thing. And so kind of a little bit newer, but it's all about 4 billion years old. So
now we talk about this being 300 plus, maybe 310, 313 million miles away. Put that in perspective for us.
Okay, so the distance from the Earth to the Sun is 93 million miles. So we're talking about more than 3 times the distance between the Earth and the Sun. It's more like the distance between the Earth and, say, Jupiter at the closest point, like when we're both on the same side of the Sun.
Amazing. Now, in fact, I heard the first image took 28 minutes to get back to Earth, when it takes a little more than 8 minutes for the light from the Sun to get to the Earth.
Exactly.
That also
exactly. So, it's all moving at the speed of light. So if it's 3 or 4 times as further away, it should take 3 or 4 times longer. And so that means you always have this terror that you don't actually know what's happening until 25 minutes afterwards.
Okay, we're all nerding out that we've landed on Comet 67P, I think, right?
Yeah.
But what do we hope to gain out of this?
There are lots of things that we can gain. I mean, this project has been in the works for a long time, so some of the other projects that have gone to comets set off after this was already planned. So some of this was predicated on old ideas, but now we can even check up on some new things we didn't expect to see. We don't know what comets really are made of, and we've got some hypotheses. We can see what boils off. A comet is basically lots of dirt and ice that's hurtling towards the Sun, and as it gets closer, it heats up and the stuff boils off. But we don't know what it's like inside, and we can learn about what it's like inside, and that helps us to understand the formation of the solar system, the formation of other planets, where life might start. There's lots of organic material, so we can investigate all of that. And then on the other side of things, we can look at, well, once we know what this is really made of, we can think more about how to move it if it's heading towards us.
We've seen that in movies.
Exactly. And I guarantee that Bruce Willis won't save us next time.
No, it's going to be scientists, I believe. All right. Now, this thing, by the way, the size of about a washing machine, they say. Of course, it's a $300+ million washing machine as part of about a $2 billion mission.
Right.
It's hard to get your brain around that. But there's a method behind the madness. There is a science, and there's a lot to be learned by this.
Right. So the lander is actually, it's about 200 pounds, a little over, and washing machine sized, and it's got these feet that stick out, and then it's got about 6 or 7 different instruments that are doing different experiments.
Have you heard the sound? They say that I've heard the transmission of a sound of the comet. I'm curious what that is. Do you think it's just in movement? But again, that wouldn't be because there's no sound in space, right?
Right. So sometimes you can transfer data into sound. So if you think about it as being, you get noises in you're transmitting things by radio, and so you're getting noises in that radio signal.
So it could be the ear to the shell concept.
Yeah.
Maybe that's what we're hearing.
Yeah.
Okay. Now, you have a kind of a personal connection to this in a way.
I do, and this shows you how long these things are in production. So back when I first started graduate school 21 years ago, I was originally working on a project that was developing one of the instruments. So the instrument that's called Ptolemy is designed to look at the isotopes. So this is the different forms of the same atom.
This is very special to you, isn't it?
It is. It's really exciting. It also interfaces with my own research, so I'm excited about that too.
I could talk to you the rest of this newscast about it. Dr. Angela Speck, we're out of time. Thank you for joining us, and I hope to see you.